Okay, so we're continuing on here in part 2 where we left off in part 1. I'd like to go on and calculate the tangent of these guys. We have the triangles drawn, 30-degree angle, standard position here. That's a 1, a 2, a square root of 3. So the tangent of 30 is going to be opposite over adjacent. That's 1 over the square root of 3. Let's highlight the pen here. Okay, opposite over adjacent. We have to rationalize that by square root of 3 over square root of 3, which makes the square root of 3 over 3. And the same thing would be true over here. So we can follow up that with a demo real quick. Being that I'm in radian mode, I can type in the tangent of pi over 6 is what 30 degrees is in radians. So pi over 6. I get that. If I go to degree mode, I would do that same thing by typing in the tangent of 30, because that's what pi over 6 is. And I want to show you that's the same thing as the square root of 3 over 3. So we can work in radians or we can work in degrees. You should be able to do these without the calculator. There is a portion of the test that's no calculator, actually the whole multiple choice part. So you're going to want to be able to do this here without a calculator, of course. All right, so we could do the same thing if I were to, let's introduce a different angle, and we'll look at a couple of others. Let's say, maybe we'll do, let's say, I don't know, 4 pi over 6. No, let's do 5 pi over 6 rather. So let's evaluate the sine of 5 pi over 6. Well, what we need to do real quick on your paper, you are going to say, well, pi over 6. First of all, that's the equivalent of 30 degrees. And remember, it takes pi radians to get over to the 180. So break that up into 6 parts. That's what this says. And take 5 of those. 1, 2, 3, 4, 5, 6. So we are dealing with a triangle. That's a 30, 60, 90 triangle right here. Here's my 30 degree. This is the 60 degree. So I do 1, 2, square root of 3. However, this is going to be negative because if I was plotting this point, I would be going left and then I would be going up. So I use this angle here. And I say, all right, sine means to do the opposite over the hypotenuse. This is going to be just regular old 1/2. We can quickly verify that, being that we are, I think we're left off in radian mode. Nope, let's change it to radians. Enter there. Back to our main screen. We'll type in the sine of 5 pi divided by 6. Just to show you that that is actually 1/2. Hope you get the idea. All right, now I've got find the 6 trig values for the function or for the angle 7 pi over 6 radians. Well, 1, 2, 3, 4, 5, 6 pi. 7 pi would be down here. 7 pi over 6. So this is what it's going to look like. We're going to use this triangle. So 7 pi over 6, once again. 1, 2, 3 pi over 6, 4, 5, 6 pi over 6, which is pi. One more, 7 pi over 6. So this is a 30, 60, 90. So we're going to go ahead and label in our angles. This one here will be the 30. This will be the 60. So I know that every 30, 60, 90 is going to be a 1, a 2, a square root of 3, except if I was plotting this point, this would be a negative, this would be a negative. Hypotenuse always remains positive. So we go here and we're going to say, all right, let's evaluate the sine first. We're going to do all 6 of them. The sine of pi over 6, I'm sorry, 7 pi over 6 is going to be opposite over hypotenuse, negative 1/2. The cosine of 7 pi over 6, actually I should be writing in those guys instead of theta, sorry about that. So the cosine of 7 pi over 6, that's the adjacent over the hypotenuse, so I call that negative square root of 3 over 2. And the tangent of 7 pi over 6, one thing we're going to show later is that the tangent of any angle is actually equal to the sine of that angle divided by the cosine of that angle. That's very true. You could actually verify that by looking at the slides on the first set of slides, which I'll revisit later on for you. But anyways, we don't need to do it that way. Let's just look at this and say opposite over adjacent. Well, that's going to be a negative over a negative, which is positive 1 over the square root of 3, which has to be rationalized. And I get the square root of 3 over 3. So now, let's separate that and let's do our inverses. The cosecant is the inverse of sine. So instead of negative 1 over 2, it's going to be negative 2 over 1, which is negative 2. The secant of 7 pi over 6 is going to be the reciprocal of this. So negative 2 over square root of 3, which I have to multiply by square root of 3 over square root of 3. I'm running out of room here, so I'm just going to write negative 2 square root of 3 over 3. And my cotangent of 7 pi over 6, this is going to be 1 over this, or the reciprocal of this, so it's just going to be, instead of reciprocaling this and then having to rationalize, use this one, because if you take the reciprocal of 1 over square root of 3, you just get square root of 3. So we should be able to take any multiple of 30, 60, or 45 degrees anywhere on this circle. It could be in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. We should be able to draw in the triangle that would result, even if it's an angle down here in quadrant 4. This is the angle we're going to use. Even if we're describing the angle wrapped all the way around here, we always use the angle connected to the x-axis. We fill in the sides and we do our SOHCAHTOA, or whatever it is we got to do it, however it is you think of it, and we can evaluate sine, cosine, tangent, and the inverse functions quite easily. So here's a little different problem here. Find the coordinates on the unit circle of the arc. And so I've given you guys a couple different arcs here. And so what we'll do, let's plot, oops, let's draw a picture of this here. So I'm going to draw a circle with that center. Now we think about where is, I should have drawn these in earlier. I'll put them in here real quick. All right, where is 5 pi over 6? Well, 5 pi, oops, there we go, 5 pi over 6 is, remember pi over 6, it takes 6 of them to get here, so that would be 6 pi over 6. Well, 5 pi over 6 is going to be right here. So I am dealing with a 30, 60, 90 triangle right here. Well, if this is a 30-degree angle right here, I drew this too small, so let me just put 30 degrees right there. If that's 30 degrees, then this is 1, this is the 2, this is negative square root of 3. So this point right here, they want us to know the coordinates on the circle of the arc. Well, the arc they're talking about is the arc that wraps around to here. So that guy right there, what's the coordinates? It's negative square root of 3, positive 1. That's the coordinates. We'll change colors here for the second one. 7 pi over 4. Well, if we think about, let me draw this differently here. Let's put these in first. That'll make it easier. And now let's put the circle. All right, so 7 pi over 4. Pi over 4 is, it takes 4 of them to get here. That means 1, 2, 3, 4, 5, 6, 7 pi over 4 right down here. We're dealing with a 45, 45, 90 triangle. So that's 1 square root of 2, except this has to be called -1 because it's going down. So the coordinates of this point here are 1, comma, -1. And one more time here for this guy over here. You'll see once you get the hang of these, this is quite easy to do. At first, I know it's very difficult, it's very foreign, but you should be familiar enough with sine, cosine, tangent that this should become relatively easy for you. All right, so here we've got a negative angle. Pi over 3 is 60, don't forget. And it takes 1, 2, 3 of them to get to pi. 4, 5 of them to get up there. So this one, when we draw it in, oops, let's fix that. So -1, 2, 3, 4, 5 would be somewhere up here, such that this is a 60-degree angle right there. Because we've only got 60 more degree angles to get all the way around to 6 pi over 3 or 2 pi. We went the negative direction. That's why we're up here instead of down here. So if I draw in these sides, keeping in mind this is a 60-degree angle. This one up here is the 30. So I've got the 1, the 2, the square root of 3, and so this coordinate right here is 1, comma, square root of 3. So you'll be asked to do something like that a few times to determine the actual point on the circle that corresponds with the given arc. And that's how it's done. It'll always be either the 30, 60, 90 or the 45, 45, 90 triangle put somewhere either in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. I think we'll save this for the third video. There's going to be a series. Again, it's more than 2 videos here. So I don't want to run out of my time limit, so I will end this video, and we will resume here in part 3.